Hello and welcome to our physical sciences session. My name is Temba. Today we shall take a look at revising some of the most important aspects on redox reaction in terms of the technique of responding to questions, how you approach the multiple choice, how you use the standard reduction potential tables. At the end of the day, we must get to a point where we are actually comfortable. So this session actually focuses on the revision part of our redox reactions, right? Okay, so in as far as the chemical change is concerned, we by now know that in a redox reaction, there is both oxidation and reduction, and the substances that are involved in the transfer of these electrons, it's your oxidizing agent, which loses, as well as your reducing agent, which gains. And then we can keep track of a redox reaction in terms of the change in oxidation number of a particular substance in terms of the loss as well as the gain. Right. Okay, so some of the terminology, as I've indicated, we'll talk about redox, your oxidation, your reduction, which are actually processes, which involves the transfer of electrons, and we shall use oxidation numbers to actually keep track of as to whether a substance gains or loses electrons. Right. Multiple choice is one of the very important skills, that you need to develop. And for us to be able to be comfortable or understand the technique in as far as, approaching these multiple choice, we need to expose ourselves to as much practice as we possibly can. In this example, we are given a reaction between ammonia and oxidation, right? And oxygen, which is an oxidation reaction. But in this question, the question says, which atom has an oxidation number of -3? Right. Now, remember, there are rules in as far as oxidation numbers are concerned. And if you are given 4 possible options, it's very important that you identify what you think of in terms of distractors. But for you to identify the distractors in a multiple choice type of a problem, you need to understand, or you need to know your stuff. Okay, now this appeals to the rules of assigning oxidation numbers. Right, so in this case, we want to identify an atom or a substance that has an oxidation number of -3. Now, let's take out those that have nothing to do with that. For argument's sake, if you look at oxygen as a molecule of an element, the rule says that if it's a molecule of an element or an atom of an element, the oxidation number is 0. So the oxygen in the oxygen in the oxygen molecule, if for lack of a better word, has 0. And then if we look at, say for argument's sake, in ammonia, we know that hydrogen always is +1. Okay, so if there's 3 of them, so if hydrogen is +1, it means then the nitrogen is -3, because the net in this case is actually 0. So if you add the oxidation number, the total of hydrogen and nitrogen, we must get 0. So there's 3 of hydrogen, meaning that in this case, the nitrogen in ammonia has an oxidation number of -3. But we can also try and verify that by looking at nitric oxide, which is a nitrogen monoxide. Oxygen in its combined form, it's -2. Then it means in this compound, nitrogen is +2, right? Hydrogen in its combined form is +1. There's 2 of them, so that the total is 0, then the oxygen is -2. So it means then our solution becomes the nitrogen in ammonia, right? Okay, and then the key terms, again, we talk about substances. Now, these substances are your oxidizing agent, your reducing agent, your spectator ions. So your oxidizing agent undergoes reduction, a process of reduction, while a reducing agent undergoes a process of oxidation. So this undergoes reduction, okay? And then this one undergoes oxidation, right? Okay. And then in the follow-up question, very same equation of reaction, identify the reducing agent. What is a reducing agent? It's a substance that undergoes oxidation. So let's keep track in terms of the oxidation numbers. Now, we agreed that nitrogen in ammonia is -3, right? And then the nitrogen in nitric oxide is +2, right? It's +2, right? Now, what a reducing agent actually undergoes oxidation. So when oxidation occurs, what happens to that particular substance which undergoes that process? Its oxidation number needs to increase. So it becomes more positive, or you can think of it in terms of becoming less negative, okay, depending on what you are given. So a change in oxidation number from -3 to +2 is an increase in terms of the oxidation number. So a substance that actually undergoes an increase in oxidation number becomes your reducing agent because it undergoes oxidation, right? So in this case, the nitrogen in ammonia is actually our reducing agent because we are keeping track of the change in oxidation number. But to arrive at that, we actually need to understand our stuff, that the reducing agent is a specific type of a species or a substance. It could be an atom, it could be an ion that undergoes a process. The process involved in this case is oxidation, which has to do with loss of electrons, right? Okay, so we are happy to say that the nitrogen in ammonia, it's not the ammonia, it's actually the nitrogen in ammonia. So it's very important, again, to ask ourselves, after selecting the possible answer, to say, what did the question say? And you ask yourself a follow-up question to say, have I actually answered the question? So it's not the ammonia that is a reducing agent. It's actually the nitrogen in that compound which undergoes oxidation. For that reason, it is a reducing agent. Right. Okay. Okay, and then we are given another reaction, which is a redox reaction. Okay. Now we are also asked that we need to identify the role of ion 3 in this reaction. Again, when you talk about the keeping track of the changes in oxidation numbers, we are saying that we are able to say whether a substance underwent loss or gain. All right, let's look at ion 3. Okay, we can immediately extract ion 3 in terms of what its state on the left-hand side of the equation compared to what happens to it on the right-hand side. So we've got Fe3+, which is ion 3. Okay, it becomes ion 2. Okay, there's only one thing that can happen. Has the oxidation number increased or decreased? It has decreased. It simply means that the ion 3 gained an electron. Okay, so the gain of electron has to do with the reduction half reaction. So what is a substance that, this is the substance that undergoes the gain of electrons. Now, it goes back again to the terminology. So the one that accepts electrons, in this case, this is what is happening to ion 3. So in other words, we can think of ion 3 as an oxidizing agent. Okay. So the role of ion in this case is that it is an oxidizing agent. And an oxidizing agent, in terms of the electron transfer, it is actually an electron acceptor, right? So it's neither a spectator. What is a spectator? Again, a spectator, remember, is those species that are not directly involved or not involved at all in the transfer of electrons. So these are some of the little ideas that you need to bring to the fore in terms of the technique of responding to multiple choice problems. Let's take a short break for now. We'll look at more examples in as far as revising redox reactions. See you after the break.